at a sample AP question here with the limit definition of the derivative, because here's the reality. Yes, you need to learn the limit definition of the derivative, but it is a lengthy process, and they're not going to test you on that, okay? Because you've got multiple choice and you've got free response. We haven't really gotten any applications yet, but trust me, there are a lot of applications in calculus that are a lot more important to be tested than the limit definition of the derivative. So you're not going to have to do it as a free response question. The reason why I do make you go through the process and do it several times is because what they will test you on is, can you recognize when something is the limit definition of the derivative? For example, looking at this problem right here. If we plug in 2, what do we get? 0 over 0. Do we know any strategies for rationalizing with e? Well, no, that doesn't make any sense, because rationalizing has to do with square roots. There's nothing that we can do with complex fractions. We really don't know any mathematical tools to simplify this expression right here to fix the problem. But what they're wanting you to recognize is this is the limit definition of the derivative. Okay, this is f of x, this is f of a, here's a, here's a. So this is the limit definition of the derivative of e to the 2x at x equals 2. Now, you don't know how to find the derivative of e to the 2x yet. You will pretty soon, but let me tell you that the derivative of e to the 2x is 2e to the 2x. So you will know that soon, so you'll be able to do this problem. After you know the derivative, then you plug in 2, and you get that e is the correct answer. Now, I use this question, this was when the AP exam used to have 5 answer choices. It only has 4 now, as reflected in your test, but that's a side note. 4 answer choices now, but this one was from before. Okay, I need you to do this warm up, okay? I want you to find the equation of the line. We've got 3 different lines here. I gave you 3 different pieces of information. So pause the video, see what you remember as far as writing the equation of the line, and then come back and check out my explanation. So the first one's really easy. We just need to plug that into our y equals mx plus b form. Okay, that's really straightforward. The second one is not as straightforward. They give us the slope, but then they give us another point. So hopefully at some point in time you had a teacher that made you do point slope form, because that's the easiest way, and they will accept point slope form. You can leave things in point slope form if they ever asked you a question like this on the free response part. So here's your x1, y1. So we've got y minus -4 is equal to 9 times x minus -1. And if it's just killing you and you have to simplify that, that's y plus 4 equals 9 times x plus 1. And if you have to solve for y, if you're one of those people, distribute the 9, 9x plus 9, and you subtract 4, so that's plus 5. Okay, so that, in my opinion, is the easiest way to find the equation of that line. And then if they want it through 2 points, then of course we have to start by finding the slope. So -3 minus 5 over 1 minus -3, so that's -8 over 4, which is -2. And then I'm going to use my point slope form. And it does not matter which point you use, they will accept that answer right there. But if it really, really bothers you, but here's something you got to remember. If you keep writing, they keep grading. So if you messed up on this and said -6 and maybe you subtracted the 5 instead of adding the 5, if you keep writing, they keep grading. So I would stop right here, okay? If they will accept that form, why not? They would also accept this. I know it doesn't look like the same line, but when you simplify it, guess what? It is, because you got 2 minus 3, which is -1. Okay, so same form right here, but they would accept either of those answers. Okay, so we reviewed that because, guess what? We're going to have to find the equation of the tangent line to a curve. Okay, the equation of the tangent line to the curve. So we've talked about the slope of the tangent line comes from the derivative at a point, but now we're going to write the equation of that line. So To write the equation of any line, you need the slope and you need a point. The slope and a point. That's all you need to write the equation of a line. So in calculus, your point will be given, or at least the x-coordinate of the point will be given. You may have to calculate the y-coordinate from the function. And then the slope comes from the derivative. You've got to get that idea in your head, that the slope comes from the derivative. Okay, the slope of the tangent line. That's the derivative. Okay, so here we go. Example, find the equation of the tangent and normal lines. If you do not or have not heard about a normal line before, it's perpendicular to the tangent line. The normal line is perpendicular to the tangent line, and if you'll remember, perpendicular lines have the opposite reciprocal slope. So it has the opposite sign, and you flip it over. Okay, opposite reciprocal slope, same or opposite signs, you flip it over. Okay, so if we have to find the equation of the tangent line at the given point. So they give us the point. They give us the xy. We've got to find the slope. The slope comes from the derivative, so let's find our derivative really quickly. Let's go ahead and use our new limit definition. Since we're finding it at a specific point, let's go ahead and use f prime of 2. So that's the limit as x approaches 2 of f of x minus f of a. Guess what? There's f of a, 5. Think about it for a minute. Over x minus a, x minus 2. Now, we can't plug in 2 right here. If we plug in 2, we're going to get 0 over 0. So let's see if we can simplify a little bit. The limit as x approaches 2 of 2x squared minus 8 over x minus 2. Guess what? We can factor. We can take out a GCF of 2. And then don't forget, x squared minus 4 is the difference of perfect squares. So that's 2 times x plus 2 times x minus 2 over x minus 2. Those x minus 2's cancel. The problem is gone. Then we can plug in 2. See, wasn't that so much faster than finding just the derivative at the point? Because what we've had to do, plug in x plus h, FOIL it, multiply it by 2, simplify it. That would have taken a lot longer. But finding the derivative at a specific point, since that's all we need, was a lot easier and quicker. Okay, so that's f prime of 2, which is the slope of the tangent line. When you find the derivative at a point, you have found the slope of the tangent line at that point. So they wanted the equation of the tangent line, y minus 5 equals 8 times x minus 2. I'm not even going to write it in slope-intercept form. I'm not going to do it. Okay? Well, actually, I just lied. Well, let's do the normal line. Okay, let's do the normal line. And then I am going to put it in slope-intercept form because I want to show it to you on the graph. I want you to see what's going on here because we've been doing a lot of math, but you need to have that connection. Okay, so the normal line slope, we don't have to really calculate anything else. We just need to do the opposite reciprocal. So if that was 8, then the normal line slope is negative 1 over 8. So the equation of the normal line is y minus 5 y minus 5 is equal to negative 1 over 8 times x minus 2. So let's put these in slope-intercept form. So let's see here, that's minus 16 plus 5, so that's minus 11. And this is, let's see here, 1/4 plus 5, which is 24th, so that's plus 21 over 4. Okay, so what I'm going to do is I'm going to graph my function. Okay, I'm going to graph that parabola that we started with, 2x squared minus 3. And I'm going to put my tangent line in y2, and I'm going to put my normal line in y3. And hopefully I did not make any arithmetic mistakes. Okay, there's our parabola. There's the tangent line, and here's the normal line. So I'm going to adjust my window because we're talking about this at 2. So I want to kind of zoom in on that. I'm going to go from 0 to 4, I'm going to change my y values because that was in the first quadrant, so I'm going to just change that to 0. And let's see if we can kind of zoom in on. So there's part of our parabola, there's the tangent line, and there is the normal line. So you can see at 2, okay, this is what we're talking about. This tangent line right here is touching the curve. I know it looks like it's touching it more in one place, but that's just because I'm not zoomed in enough. But it's touching right there. That's the tangent line. It's gonna hug the curve, kind of. It's gonna be really close to it, but it only touches at one point. Here's the normal line coming across. Notice they intersect right there at 2 on the curve, and hopefully you can kind of see that they're supposed to be perpendicular to each other. I don't have a squared up window. Let me zoom square, see if it'll do it without totally wrecking things. Okay, it's a little bit easier to see here, maybe, that those two lines are perpendicular to each other, but that's what's supposed to happen. The tangent line and the normal line are perpendicular to each other. Okay, so a lot of information there. Let's do one more, okay? F of x equals 5x squared minus x plus 4 at the point 1, 8. So again, we've got our point, we've got our x and our y, so we need the derivative, f prime of 1. So that is f of x, whoops, the limit, I keep on forgetting my limit. The limit as x approaches 1 of f of x, 5x squared minus x plus 4, minus f of a is 8, okay, over x minus a. So let's simplify the numerator there, combine some like terms, 5x squared minus x minus 4 over x minus 1. Now, some of you may be intimidated by trying to factor that numerator, but guess what? Remember what's supposed to happen here. That x minus 1 has got to cancel. It has to go. So that means x minus 1 has got to be one of our factors. So if x minus 1 is one of our factors, our other factor has to be 5x, because x times 5x is 5x squared. And this other number has to be 4, because 1 times 4 is the only thing that's going to give us 4. And it was a negative 4, so the 1's already negative, so that's got to be positive. Now you can, of course, go and check it, do the outside and the inside. Negative 5x plus 4x, that's negative x. So it does check out. So our x minus 1's cancel. Then we can plug in 1. Okay, 5 times 1 plus 4 is 9. So that is the slope of the tangent line. I'm going to keep writing it because you've got to get that ingrained. Okay, the slope of the tangent line at x equals 1. If we'd done it somewhere else, we would have gotten a different slope. Okay, if you'd done it anywhere else, you would have gotten a different slope. So the equation of the tangent line is y minus our y value is equal to the slope times x minus the x value. Okay, so that's the tangent line. The normal line is y minus 8 is equal to negative 1 over 9 times x minus 1. So same thing, just the opposite reciprocal slope. Okay, so I want you to try textbook page 131, 25 through 31 odds.